Okay, so in this video, now we've established what the differentials of each of the trig functions are, we're going to have a look at applying this to functions and powers of trigonometric functions. Okay, so let's make a start. Let's start with y is equal to sine squared x. Now the first thing to remember with y is equal to sine squared x is this just really means, this notation means y is equal to sine, oh dear, this isn't working very well, is it? Sine squared x. Okay, so when we differentiate this, it's just going to work exactly the same as when we differentiate x squared or anything within the chain rule function. We're going to bring our power down and reduce our power by 1. So that's first part of our chain rule. The second part of our chain rule says, right, now you've differentiated the thing squared, you need to differentiate the function inside the function, the composite side of the function. So now we need to multiply by the differential of sine x. Well, sine x is just cos x. So when we differentiate it, we can literally just see we've got 2 sine x cos x. Right, let's have a look at another one. This time we've got cos cubed of 4x, and we're going to have a look at differentiating that. So remember that this is just cos to the 4x cubed. Now this is interesting because this is a composite function of a composite function. This pen is really causing me a few problems. So let's have a look at differentiating it. So the chain rule says differentiate the whole function to start off with. So bring the power down, leave the function as it was, reduce the power by 1. Now multiply by the thing that's inside the bracket. So if I multiply by the thing that's inside the bracket, the differential of cos is minus sine 4x, but we're not done because now we need to deal with the function inside the function, so this bit. So we need to multiply by the differential of 4x, which of course is 4. So to put that all together, we have got minus 12, because we've got 3 minus and 4. And then we've got sine 4x. I'm going to bring that to the front because it's not got a power. And then we don't write cos 4x squared like that. We write cos squared 4x. And to recap, this is because this function here is literally just a function of a function of a function of x, where h of x is equal to 4x. So h dashed of x is equal to 4. G of x then says do cos x. So the differential of g of x is minus sine, but in this case we were putting in g of h of x, so we were getting cos 4 of x, giving us minus sine 4 of x. And our final function, f of x, well, that just said take whatever you pop in and cube it. So this was like x cubed. So this said times it by 4. This said take the cosine of it. And this said, once you've done that, cube it. So to do the chain rule, we need to differentiate the thing inside the bracket, the thing that's in yellow, and then differentiate the thing that's in white, the 4x. If you're not sure about that, then try using it with the chain rule. Right, let's do some for you to try. Okay, here's one for you to try. Y is equal to root sine 4 of x. Pause the video, have a go, and let's see if you get the right answer. Okay, well the first thing I'm going to do, as I always do, is rewrite this into a power, just like we would at C1. So this is really sine to the 4x all to the half, so we could put a half in there in the usual notation. So when I differentiate it, the first thing I'm going to do is differentiate the power. So I'm going to bring the half down, leave the function as it was, and take away 1 from the power to give me minus a half. But I'm not done. I now need to differentiate by my function that was inside my brackets. So inside my brackets I had sine 4x, so I need to differentiate to sine 4x. Well, that's just cos 4x. So that's the first thing I need to do. This pen is really giving me some jip. And then I need to multiply by the function that's inside that function. So if I multiply with the differential of 4x, I get 4. So my final answer is going to be, well, 4 times a half is 2. And then I've got cos 4x on the top. And because this guy is minus, I can put this all over sine 4x. And because it's minus a half, all over root sine 4x. I'm going to show you that longhand if you didn't quite understand it. If not, then you finish the video and you can have a go on some on page 87 of your textbook. If not, I'm going to go through that a bit slower at the end of the video, so just keep watching if you want that explained again. Okay, let's do this a bit more slowly for those of you that need it. This is actually a function of a function of a function. And let's just have a look. The first thing that we do with this function, if you like, f of x, says take x and multiply it by 4. So that's that bit there. The next function that we do says take x, so let's call it g, we can call it anything we like, but let's call it g, and sine it. Whatever you input into, I want to do the sine of it. And the final function says, okay, take x, I'll call this h of x, take x, and square root it. So we have got this y up here is actually saying do f of x, times it by 4, then g it, and then h it. So if we want to do the chain rule for this thing, then we're going to need to differentiate f, differentiate g, and differentiate h in order to get the final differential. So if we do all of that, we will get f dashed of x is equal to 4, g dashed of x is equal to cos x, and h dashed of x is equal to, well, you bring the half down and then take away a power, so you would get that, or you might call that 1 over 2 root x. Okay, so if we put all of that together, we need to first of all say, okay, I'm going to differentiate my h first. So that's this bit here. So I'm going to get 1/2 times 1 over the square root of everything that I've put inside of my h. So that's gf of x, so that's sine 4x. Now I need to multiply that by g dashed of x, which is cos x, but it's not cos x, it's cos 4x. And then finally, I need to multiply it by f dashed of x, which is 4. So when we simplify that, we get 2 lots of cos 4x all over root sine 4x, just like we did in the first part. Try some on page 87 and see how you get on.